Uh, I want to start with just saying all of you are just a bunch of idiots. Like honestly, by God, you're idiots. Like since the last 3 weeks, I've been hearing about cell phones, cell phone technologies, and sports benefits of technology. What's wrong with you people? Come on.
What are you going to talk about?
Huh?
What are you going to talk about?
I'm getting there. Hang on. Alright, what I'm going to talk about is a time machine, right?
Oh, is that
Something that doesn't even exist.
It's going to be... Let's have like a two-way interactive discussion at the end. Alright. Time machine. Though time machine has not been invented yet, so what my main focus in this presentation is time traveling. Alright? Time travel. Alright, time travel is... Oh, sorry. Hang on. What is time travel? Yeah, I missed one. Alright, I'm going to talk about time travel and what is time travel? Anyone? Who has... Do you know what time travel is? Alright, fine, you're idiots. I'll tell you what time traveling is. Every minute that I'm talking, I'm actually traveling in time. At a constant rate, I'm actually traveling a bit into the future. Because what I said, when I said all of you were idiots, that time has passed away. Now we're at a different time, at a different place. Not a different place, but at a different instant of time, right? So why is this such a big deal? Time traveling, what we try to see it as, picture a number line, right? From 1, you want to go from 1 to 6 without crossing any of the numbers in between. That is time traveling, or if you want to go in reverse. That is what we mean when we say time traveling. Alright? Is that possible? Is time traveling possible? What do you guys think?
No.
I just said we're already, traveling in time in a constant rate.
But the backwards time traveling, skipping time is
Alright.
not that possible.
It's not been tested yet. No one has any practical examples of proper time traveling. Well, there is one. I'll get to that. But in physics, how we understand the universe is scientists don't know anything, and in physics we understand the universe by theories. By here's an idea. The universe works this way. Let's see if it works. Let's see if the theory is correct or not. So one of the theories which helps you, which kind of says you can travel in time is general relativity, and it says if you travel faster than the speed of light, you will be able to travel backwards or forwards in time, like I just discussed, jumping without going through time at a rate which we're already doing. Alright, faster than light travel, I can't go to the mechanics of it, the numbers of it, but how I'm going to tell you this is, Horace told me a very good example, how we can imagine traveling in time, just like a good practical example, right? So I call it the Jallianwala theorem, alright? You have the Earth, right? You're looking at it, and let's say, I have to look light. Okay, you're here, right, in orbit, and you start off here, and you go all the way around the planet. This is what Horace said. You go all the way around the planet, right back where you started. If you do it fast enough, you'll actually see yourself disappear. You'll be there to witness yourself disappear and go around the world. That could be that is one way to understand how faster than the speed of light time traveling works, right? Another theory would say is using wormholes. Who knows what a wormhole is?
I have an idea.
Alright, I'll just tell you, I'm sure most of you don't know. Not that it's a bad thing, I just like this stuff, that's why I know. Einstein said, let's say you have space, like a thread of space, like three-dimensional space in your right hand, and and time in your left hand. Strings, just picture them as strings instead of space and a clock for time, right? Think of them as simple strings, and you make a piece of cloth out of it, a fabric, by intertwining the strings together. You have what he calls the fabric of space and time. And like any fabric, it's not a pure thing. It has holes, it has depressions, it has all kinds of things in it. So these holes in this fabric of space and times are called wormholes. If I enter this hole right here, some laws, I don't know what, we don't even have names anymore, won't let me exist outside the space-time fabric. So it'll push me back in to the fabric from another hole, like right back into the fabric in a different place, as you can see, different place, also in a different time. That's how kind of, but also works in time. Yes.
How you are going to find the right hole?
I never said you. Yeah, I never said you would need to find the right hole. I'm just saying, hey, it can happen, right? Right hole. Let's see. Like Stephen Hawking said, I saw a documentary. He said these holes are literally microscopic and all around us. In this room, there are like a billion of these holes. They're so small, they're everywhere, right? So, hey, it's not hard to find a hole. Mass and time phenomena. This is very interesting. This, if we had the funds to practice it out, we could actually travel into the future. This is a one-way trip. We could actually travel into the future. Einstein or some guy said, like, time is not constant around the universe. Like at one place, if every second, like I eat something at a constant rate, right? So more like I do something at a constant rate. I juggle a ball at a constant rate, like one every second. Over there, it might be something else because the time is different, not my rate, because my rate is dependent on the time. That's why blah blah blah. All right. A better way to understand it is like just to tell you what I mean is. We have the Earth, right? Earth. The problem here is black holes on a black screen. Alright? No, but don't worry, I put a picture there, I'm just joking. Alright? Alright. This is a black hole, very massive, and this is your planet Earth where we know what the average rate of time is. I'm here, I get on a shuttle in the year 2011. And I travel all the way in, like, let's just say it takes me an hour to travel all the way to this black hole, and I start orbiting it for a year. For 1 year, like I have a clock with me, when it says 2012, October to 27, I'll go back. And when it does, it takes me another hour to come back, like 1 year there, 1 hour and 2 hours, 1 year and 2 hours, traveling time, whatever, and I come back. The time here would have been the date here, the year date, whatever, would be either 3011 or something, kind of like that, roughly. I don't know the exact number, but kind of like that. Depends on the size of the black hole. We don't know why that happens, or maybe we have some ideas, some theories to back it up. But yes, it does happen. Next to, like, Adil's sitting next to Haris, he's more massive, so Adil's probably going at a very slower rate than. Where's Sabit? Alright. The guy next to Furqan. Furqan racing. So Furqan would be going at a higher rate than Adil. Alright, let's move on. Experiments on time travel. Experiments on time travel can be categorized in two major ways: scientific and non-scientific experiments. Scientific experiments. Let's just not talk about that. Too many numbers, too much crap, right? Other experiments. Stephen Hawking said, if we were to ever invent a time machine, we do it in the future, we'll travel back in time and just tell ourselves about it, right? Or we'll probably see a guy from the future saying, hey, time travel is possible, at least try, something like that, right? He actually organized a party, like a few years back. He said, let's organize a party and invite, and he sent out an invitation on newspapers. He said, hey, time travelers from the future, if you ever invent a time machine, I'm organizing a party on this date, at this place, and if you can travel time, come back to this time and meet me here. We have free champagne and whatever, it'll be fun. and I'm not making this up, this actually happened. This actually happened, right? But sadly no one came, as you can see. It's all alone, right? No one came, except the guy taking the photo, all right? Okay, why time travel may not be possible? Well, the only fun or like the only interesting issue I could see was paradoxes. That's my favorite word for today. Paradoxes, all right. Let's say I invent a time machine today. I go back around 1945 and I kill my grandfather right before he met my grandmother. I wouldn't have been born, right? Right? So how could I go back in time and kill my own grandfather if I was never born? You guys get it?
Yeah.
The time paradox. Well, that's pretty much it. Question and answer.
Your paradox suggests that there might be parallel universes.
Yes, it does.
So there is no parallel universe according if we look at that.
How do you?
Because there has not been a proof of a parallel universe.
There hasn't been a proof of. Well, like a year ago, there wasn't any proof for anything traveling faster than the speed of light. Now there is. What? Not having proof of something isn't proof of it not existing, right? You're smarter than that. Any questions? Sir, questions? Just one question, nothing? Probably a flaw in. Thank you.